133 and 135 are both the limicons, right? The 133A is 5 and B is 4. So 5 over 4 is bigger than 1 but less than 2, right? This would be a dimpled limicon. It's cosine, so it's symmetric to the polar axis. All that stuff you're going to have on your answer sheet in the box. Okay, what kind of what kind of equation it is. If it's a limicon, is it convex, looped, dimpled, or cardioid? Did I get them all? Yeah. And then also the symmetry. So all of that should be on your, yeah, Taylor.
I get like how to write like the symmetry for cosine, sine, but what does it really mean?
It means, so for this one, it means the polar axis is my x-axis, right? So it means whatever coordinate points I find up here, I can duplicate down here. So it literally cuts my work in half.
Oh, okay. So once I find that side, I just flip it over.
You just flip it over. Yeah. So I'm going to actually, I should have just pulled in the polar. And by now I should have favorited this, but I haven't. So I just keep digging. Yeah. Okay. So we've got this one, right? So because it's symmetric to the polar axis, I'm going to plug in points from my first quadrant and my second quadrant and then flip them over. If it was symmetric to the pi over 2 line, I'd plug in points from my first quadrant and my fourth quadrant, the right side, and then I'd flip it over to the left. So polar axis, I would do 1 and 2, and then flip it over. Pi over 2, so if it had sine in it. Pi over 2, I'd do first and fourth quadrant, and then flip it over the pi over 2 line. So again, this one had cosine, so I'm going to plug in, and it's not inner loop. I told you yesterday, inner loop I would do the over 6s and the over 3s. The other ones, you're going to be fine by doing 0, pi over 2, pi, and then the over 4s.
Wait, so can you say that one more time? So
Yeah.
If you have cosine, you only do like...
Cosine, you're doing first and second.
The symmetry from like side to side.
Quad 1 and quad 2 for cosine, and then flip it over.
Mm-hmm. And then
Sine,
is
quad 1 and quad 4, and then flip it over. And then as long as it's not an inner loop, you do the quadrant angles and the over 4s. If it's an inner loop, you're going to do the quadrant angles, the over 6s, and the over 3s because you need to find that little loop. Okay, so now I'm going to plug in those points. So I'm going to take my r equals 5 plus 4 cosine theta. And I start with 0. The order here doesn't really matter, but 4 cosine 0. That coordinate point is 1, 0. So 5 plus 4 times 1, and that's 9. So 9, 0 is my first coordinate point. Then I plug in pi over 4. R equals 5 plus 4 cosine 5 pi over 4.
if it was sine,
No, pi over 4. I don't know why I said 5 pi.
would it go like 0, 9? And would it go to the y?
No, it always goes radius and then angle. So
Oh,
that's
the
r. This is
angle.
r theta.
Got it.
Yep. Then cosine, so this would be root 2 over 2 and root 2 over 2. And you're going to know that because you should know your unit circle by now because I'm shoving it down your throat. Or you're going to look at your unit circle and you're wasting your time, but you're going to do it one way or the other. So now I get 5 plus 4 times root 2 over 2. 2 goes into 4 twice. 5 plus 2 root 2. We said we're going to approximate root 2 to be 1.4. So 5 plus 2 times 1.4. And that's 7.8. 7.8 pi over 4 is my second.
Why did you multiply it again?
This one.
Yeah.
So it's 4 times that, right? So 2 went into 4 twice. So it's 2 times root 2.
Mhm.
And we approximate the root 2 to be the 1.4. So then it's 2 times that. So if you forget your approximations, that's where your calculator can come into play. But you also can just remember root 2 and root 3. Those are the only roots you're going to get that you're going to approximate. Root 2, 1.4. Root 3, 1.7. And if you want to make it even, 1.8, that's fine too. You're not going to get that precise.
And root 3 is 1 point.
1.7, yeah. All right, now I'm going to go to pi over 2. R equals 5 plus 4 cosine pi over 2. Cosine at pi over 2 is 0. And I get 5. So 5 pi over 2 is my third coordinate point. Then I go to 3 pi over 4. 5 plus 4 cosine 3 pi over 4. That's a negative root 2 over 2 for the cosine. 5 plus 4, negative root 2 over 2. 5 minus 2 root 2. We already did 2 root 2. That's that 2.5 or 2.8. So this is 2.2, comma 7 or 3 pi over 4. And the last one is pi. Coordinate point at pi is negative 1, 0. 5 plus 4 times negative 1, 5 minus 4, which is 1. And 1 pi is my last coordinate point.
How'd you get 2 pi right?
Root 2 is 1.4, and then 2 times that. We just did it up here, so I just used it again down here. But root 2 is 1.4, and then 2 times 1.4 is 2.8. You with me?
In 20 seconds.
Okay.
Honestly, I do not know why this chapter just never clicked in my brain.
You have 24 hours to make it click. No pressure.
Okay, it's like, I get how to do it.
Yeah.
I feel like I could speed it up if I understood the symmetry thing.
Yeah.
Like, how do I know when it's symmetric to pi over 2?
So if it's got an r and not r squareds are different, right? But if it just has an r and the word cosine is there, it's the polar axis or the x-axis. If it's r and sine is there, it's pi over 2 or the y.
Oh, so sine defaults to pi over 2.
Yep. As long as r is not squared. When r is squared and when it's the limnus gate, it's different, which I'll go back to it after we do this, but yeah. We ready to plot those points? Yes. Okay, so 9, 0 is the first one. On the 0, which is the angle, I'm going to go out to 9. So this one doesn't have it, but I'm going to go like, say this is 6, 7, 8, 9. So my coordinate point's all the way over here. Then 7.8 and pi over 4. I'm on the pi over 4 line. Again, it's not big enough, but let's say this is 6, this is 7, this is 8. So 7.8 would be about there. 5 and pi over 2 is here. 3 pi over 4, I want to go to 2.2. And at pi, I want to go to 1. Now this is where the symmetry comes into play. Everywhere there's a coordinate point above the x-axis, I'm going to mirror it down underneath the x-axis. So I'm not going to do this to the ones that actually are on the axis, but everything that's not on the axis that's above it, I'm going to flip to be below it. So this coordinate point here, that's on my over 4 line at 2.2, I'm going to go below on that over 4 line, 2.2, and I'm going to plot a point. Then the top coordinate point here, which is at the pi over 2, 5, is going to go down here to 3 pi over 2, 5. The pi over 4, and that was like a 6, right? 7.8. So I'm going to come down here, 7 pi over 4. This is 6, 7, 8, so it's like here. And then that last one is on the axis, so it stays there. Now my job is connect these to make it a dimpled limicon. So this part makes like almost that rounded curve. This is going to come in and be smooth because it's dimpled. And then I'm going to come around. That wasn't very good on the bottom, but you get the point. The biggest thing is if this was a heart, I would know to come in pointed, okay, on that curve. If it was convex, it should be flattened out here, so my coordinate point should make sense there, okay? And then if it's the inner loop, I'm going to have more points in there to find that loop.
Is there an extra step, or is that it?
That's it?
You sure?
Yeah. Yeah.
Okay.
Yeah. So when I'm grading this mess of a question, I'm looking that you classified the correct kind, right? That you found the symmetry, that you plotted points, that you flipped them over, and that you connected them to make that overall shape.
What's the other options of symmetry? Polar axes
And then pi over 2. So if it was sine in there, this whole thing would have gotten rotated 90 degrees so that the little lip dimpled thing was at the top or the bottom, depending on the signs. So it would have been a shape like this. Or it would have been upside down, depending on the positive negative sign. Something horribly shaped like that.
I just don't remember the slide that's like symmetry. The pi over 2 or the polar axis.
So sine pi over 2, because sine is the y, right?
Yeah.
Sine is y, pi over 2 is the y-axis. Cosine is the polar axis, cosine is x, polar axis is the x-axis. The time that changes is for a lemniscate. So when it's an r squared, if it's r squared with a sine,
What
it's
would be the R
only,
squared in the test?
you're either getting a rose or a lemniscate. Yeah, so you got a 50-50 shot there. This would be symmetric to the pole instead of the pi over 2 line. If it's r squared and it has cosine, it's symmetric to the pole and to the polar axis. So this one is your diagonal infinity. This one is like that or like that. Yeah,
Let's say I just go blank.
don't do that.
I won't. But like to this topic,
Yeah,
if I just plug in points, will I eventually just figure it out?
yeah.
Okay. I'm gonna try it that way.
So my advice is if that does, 1, don't do that. 2, if it does happen, do all the other questions first, go back to it. Because 1, you don't want to leave them blank. 2, else it's going to take you a long time.
Okay.
Yeah. Yeah.
It's a strategy though.
Mm-hmm. It's an interesting strategy.
Caroline, you are sorry to interrupt.
Yeah.
Oh, awesome. Thank you.
You're welcome. You're welcome. Got a whole handful of those.
She has a lot.
Yeah.
So is the one with like the loop the only one where you want us to do pi over 3 and pi over 6
Yeah.
points? Okay. And
Don't-
the other ones are just pi over 4 then, right?
Yeah.
Okay.
And 5 pi over 4 or pi over 4 and 7 pi over 4.
And then like the pi over 2 pi and all that.
Right. The quadrant angles you want to do. Yeah. So do I need to do another one?
Yes.
Yeah. 135. R equals 3 minus sine theta. This is,
A lemniscate.
no.
What?
Lemniscates are r squareds.
Oh, wait, no, what's the thing called? The one where you add I forgot what it's called.
So this would be 3 over 5, which is less than.
Yeah.
So it's a limison what kind?
I don't have it memorized.
So for me, I don't know if I did this trick with you guys, but for me, when I visualize it, I start with the loop is all the way at the left, and then imagine somebody is pushing that little loop out. The shape it takes on after that is the heart. Then the shape it would take on after that, if it kept pushing out, would be dimpled, and then the shape it takes on after that is the convex.
Oh, wow.
So this is the smallest A over B. A over B less than 1, and it's that loop. A over B equals 1. Remember, they're a perfect match. That makes the heart. They have fallen in love. Yes.
So it's a card.
If it's in between A over B, if it's in between 1 and 2, it's the dimpled one. And if it is bigger than 2, then it's convex. This dimpled is not a very good dimpled, but you get the point. Okay? So is 3 over 5 less than, equal to, in between, or greater than?
See,
Which one?
that's the problem. I can't even divide through it. So I was like.
Is 3 over 5 bigger than 1?
Yes.
Is less than 1.
Less
Yes?
than-
3/5. If you have 3/5 of something, you don't quite have a whole. Yes?
Yes.
Yes. So this is an inner loop.
Where did you get the 5? Oh, that's a 5.
So the A is the number on the front, the B is the number attached to it. You ignore the signs. Positive, negative do not matter when you're classifying. And then this is when you're like, crap, we pulled the short straw. Because you got an inner loop, which requires a little bit more work.
More plumbing work is why.
Symmetric would be what? Symmetry 2,
Power.
pi over 2, because the word sign is there. So now I know I'm plugging in from first quadrant and fourth quadrant and then flipping over the pi over 2 line. So I'm going to start by plugging in 0. I'm going to do pi over 6 because yuck, it's a inner loop. Pi over 3, pi over 2, 11 pi over 6, 7 pi over 4, 5 pi over 3. Oh, I don't need to do the 4s. Sorry. And 3 pi over 2. And now I'm going to plug them in. Coordinate points, you would already have them on your unit circle, or you know them because you're smart and you need to know them. And you have learned maybe nothing else this year but maybe the unit circle. Yeah, I know. I hate this. This is one of the reasons I hate this year. Okay. Root 3 over 2, negative 1/2. 1/2, negative root 3 over 2. 0, negative 1. Okay, again, those will be on your unit circle that you're going to have printed ahead of time because you need it. And I would add on the tangents, not for this question, but for the other questions, I would definitely add on the tangents. When we do the conversion, you need it. Okay, so I'm going to work kind of fast through the plugging in. R equals 3 minus sign. I'm going to start at 0. Sign at 0 is 0. 3. So 3, 0 is my first point. R equals 3 minus sign at pi over 6. Oh, wait, I forgot the 5. Sorry.
That switches everything.
Yeah, well, it didn't matter the first time, luckily. Yeah, it was 0, but this time it would have gotten me. All right, pi over 6, sign is 1/2. So this is 3 minus 5 halves, 3 minus 2.5, which is 1 1/2. And that's at pi over 6. R equals 3 minus 5 sine pi over 3. 3 minus 5 root 3 over 2. 3 minus, and this is going to be 2.5 times root 3. We said approximate root 3 to be 1.7. 2.5 times 1.7. 3 minus 4.25, negative 1.25. And pi over 3. And then R equals 3 minus 5 sine pi over 2. Sine is 1 there. 3 minus 5 is negative 2. That's my first quadrant. Then I got to do the fourth quadrant. R equals 3 minus 5 sine 11 pi over 6. 3 minus 5, the sign there is negative 1/2. 3 plus 2.5 is 5.5. R equals 3 minus 5 sine 5 pi over 3. Negative root 3 over 2. So this becomes 3 plus 2.5 root 3, which we already figured out over here was 4.25. 7.25. I know, but that hopefully the plugging in is not the part that I mean, you just gotta be careful, but
It's a lot of work.
yeah.
I'll just for one phone. We'll be fine.
You will be fine.
Hopefully the printer doesn't have enough ink to do this.
I was gonna say I already printed it because normally I do already print it, but I didn't print it yet. So it's could be really interesting. I don't know how it would have enough ink to print any other limicon, but not
No, like the
the
chart.
inner
and then
loop.
We'll veto.
Oh, no.
We'll be like, no charts.
I'm not giving you a chart because if I give you the chart, you'll know what kind to plug in.
No, I just hope
Oh,
it
where's
forgets
my
this.
No, like
square?
the blank-
I don't know.
There's no. I'm not giving you a T chart. Is that what you mean?
No, not a
Oh,
chart. Like
the polar grid,
Yeah, like no, just like
the circle.
a little like that.
You have to have that. I'll hand draw that crap before I let you not have any graphs.
No.
Okay, now I gotta plot all those points. Three, 0, 1.5 pi over 6, pi over 3, and negative 1.25. So I'm going the other direction, away from pi over 3. Pi over 2, negative 2. 11 pi over 6 and 5.5. 5 pi over 3 and 7.25. Oops. 6, 7, so like here. And 3 pi over 2 and 8. 6, 7, 8. So everything that is to the right of my axis is going to get duplicated over to the left of the axis because it's symmetric to the pi over 2. So at pi over 6, I had that like 1.1.5. I'm going to do that at 5 pi over 6. At 0, I had 3. So at pi, I'm going to have 3. At 11 pi over 6, I had 5.5. So at 7 pi over 6, I'm going to 5.5. At 5 pi over 3, I was at 7.25, so 6, 7.25 at the 4 pi over 3. And then my little point inside on the left has to get duplicated onto the right. So on that 4 pi over 3 line, we had the 1.25. We're going to put it over here at the 5 pi over 3 line. And then I get my inner loop. At the end, I always mess up, but you get the point.
That's great.
A rose. 137 is a rose. And you know that because it is r, not r squared. But there's a number in between the cosine and the theta. So remember the limicons, you're adding and subtracting things to the front, right? The rows, you get a number in between the cosine and the theta, but the r is not squared. The r is raised to the first power. So this is a rose, and I don't know why my highlighter's not working. Let's see.
Mr. Schweizer?
Yeah.
So when I'm, graphing a rose,
Yeah.
for the work, I only find one petal, and then I use like symmetry and like almost common sense to find everything else. Is that enough work to show, or do you have to show the work for everything?
That's enough. If you had extra time, I would plug in where you think the other petals are just to be sure. But as far as credit goes, as long as you show how many petals, the length of the petals, and then find the one petal by setting it equal to that length, that's enough for me.
All right, thank you.
You're welcome.
And then same thing for the limnescape, right?
Same thing for the limnoscape. Yep.
All right.
So this one's a rose, right? So this is a rose. We need number of petals, length of the petals, and then find where one of those petals are. And then use your symmetry to figure out what the rest of that shape looks like. For 139, this is your lemniscate. So you find your, this time the number on the front is a squared. So that's the length of your petal or your loop, okay? And then you would figure out your symmetry. So 130, that's why you're only getting one or the other. Like you're either going to get a rose or you're going to get a lemniscate. They're pretty similar. You want to figure out the length of that loop or that petal. For the rose, you want to figure out how many there are. For the lemniscate, there's going to be 2. And then you want to set them each equal to that length, solve, and find where that loop happens, and then use your symmetry to find where the other loop is. And then the last one is that, like the circle up here. Hopefully that one's easy. That's literally to the right, go to 5, draw yourself a circle. Do you want me to do the lemniscate or the rose? Like which one? I wish I knew which one you had, and then I could like subliminally go over that one, but I don't remember which one you guys got.
Let's see which one.
Can you do any rose?
Do the rose? So 137 r equals -3 cosine 2 theta. Okay, so it is a rose. It has 4 petals because we double it if it's even. The length of the petal is 3. I know that says -3, but there's no such thing as a petal length of -3. It will come into play when we find the angle. But for right now, we just need that the length, and that should be A, sorry. A is 3. That's the petal length. It's got cosine, so it's symmetric to the polar axis. Which means if it's got 4 petals, it can go 1, 2, 3, 4. It could go like that. Or it could go 1, 2, 3, 4, like that. Those would both be symmetric to your polar axis. So now we want to figure out where it's happening. So we set R equal to the arc, the petal length, which is 3. So 3 equals -3 cosine 2 theta. Divide both sides by -3, and I get -1 equals cosine 2 theta. So now we're saying, give me the angle where cosine is -1. Cosine's -1 at pi. So pi equals 2 theta. Divide both sides by 2. And theta equals pi over 2. So I plugged in 3. I got out of it pi over 2. That's telling you one of the coordinate points is 3 pi over 2.
So, because if that was like +4, you would still put the plug-in to R -4, or just also?
No, I would plug in whatever R is. So it would be the length. It would be +4.
Okay. But the reason why didn't you add the negative? I think you said it, but
Because length is not negative,
Okay.
right? Length is just a distance. So now I know that at pi over 2, I'm at 3, which tells me I have a petal here. It has to be symmetric to the polar axis, so the other petal is happening here. And then there's 4 petals, which means the other ones have to happen here and here. Now with the extra time, what I could do is plug in 0, plug in 3 pi over 2, and plug in pi, and see if I get those points. So if I were to just plug in 0, for example, into my original one, right, R equals -3 cosine 2 times 0. R equals -3 cosine of 0. The 0 at cosine is 1, -3 times 1. So -3, 0 is a coordinate point. 0 is over here, work my way opposite direction, 3, and there's one of the petals we thought was happening.
Why'd you go negative? Why'd you go to 3 and 4, not 1 and 1 and 2?
So, you mean like why to go that way?
No, why'd you go, for example, to 3 pi 2 over instead of pi over 2?
Oh, just to check it. Is that what you mean? I already had pi over 2. This was this point.
Oh, okay.
Then I said it has to be symmetric to the polar axis, so it also goes down there. And the only other way to get 2 petals that are symmetric to the are there. If you have 4 petals and it has to be symmetric to the x-axis, it's literally either going to be this shape or this shape. And we ruled out that bottom.
Why'd you have to plug in though if you knew that?
So I said only if you had extra time and you wanted to make sure, then you would plug in. This part you have to do. The finding the first petal you have to do. Whether it's a lemniscate or a rose, that part you have to do. We're gonna do 139. Okay, so it's the r squared, which tells me it's a lemniscate. Okay, this time symmetry is different. If it's the r squared, it has pole symmetry, which means everything that happens in the top right happens in bottom left, bottom right. Okay, if I folded it along the y equal x or y equals negative x line, it would overlap. That's what pole symmetry means, to the origin. Then because it's sine, that is the only symmetry that it's guaranteed to have. Remember, it could have the other stuff, but it doesn't have to. If that was an r squared and a cosine, then the lemniscate would be symmetric to the polar axis. It's going to happen on the x-axis or the y-axis. This one is corner to corner or corner to corner. The length of the loop, you could call it a petal, I don't care what you call it, is the square root of what's in front of the sine. So it's the square root of 5, which we'd approximate to be like a 2.1, a 2.2. It's just bigger than 4, right?
At a 2.2.
Yeah, we're going to approximate it when we graph it. It's a little bit bigger than root 4, so. But when we plug it in, we keep it exact. So to find the loop, we plug it in as square root 5. Square root 5 squared equals 5 sine 2 theta. Square root of 5 squared brings it back to 5, which is what should happen. Divide both sides by 5. 1 equals sine 2 theta. Sine is 1 at pi over 2. So 2 theta equals pi over 2. And I get pi over 4. For theta, it's this lemniscate. Pi over 4 and root 5. So pi over 4 and a little bit bigger than 2. There's one loop. It's symmetric to the pole, which means the other loop's happening on the other side in that third quadrant at that over 4.
But what's the equation, like the r with theta? Is it, like, I know pi over 4 is...
It's
big.
root 5. So if I wanted to check, I would check 5 pi over 4. I would do r squared equals 5 sine 2 5 pi over 4. R squared would equal 5 times the sine. This would be 5 pi over 2, 2.5 pi, which is 1. R squared would equal 5 times 1, which is 5. And R would equal square root 5, which we again approximate to be like a 2.1, 2.2, which confirms our shape. Questions for me? I know we didn't answer a lot of 10-1. I feel like about it. So 3 is just a way to word it. You're going to do it from a graph. But if it said 3 units to the right, that means you're moving to the right 3. And then 5 units behind means you're moving back. So it would be like -5, 3, and then you didn't go up or down at all. But you won't. You'll get it from a graph. So as long as you can identify that coordinate point from a graph like we showed yesterday, you're good. I wouldn't worry about those. This, yes. This, yes. This, yes. Those are the 3 plus the coordinate point from the graph. Everybody's good? Yes? Good? Yes? Okay. Okay. Don't forget, tomorrow you need to be on time. Obviously, I have you second, so there should be no excuses for arriving tardy tomorrow. Okay. Please make sure you print your answer sheet so that you're ready to go. No calculators. Be on your second device if you're taking this at home. Anybody know they're not going to be physically in the building tomorrow, so I don't have to waste that paper? or hand draw any more polar graphs. Okay. I was going to say who's at home. That's normally here, but no. All right, so tell me what you need. I could post the GIMP kit. I don't know that it's like a great review. It was just more just for fun. The extra graphing, Amanda, that was on the assignment, right? All right, so x squared and negative 4x. And then y squared and negative 6y. And then the z is by itself. There's no z, there's the z squared, sorry, is by itself. There's no z, which means I'm not going to have to complete the square and the z. That gives me a z of 0. The 4 goes to the other side, so I get negative 4. Now I complete the square. So 4 divided by 2 is 2. 2 squared is 4. Add it here and here. 6 divided by 2 is 3. 3 squared is 9. Add it here and here. Factor, so square root of the first, square root of the last, sign from the middle, put it in parentheses and square it. Square root of the first, square root of the last, sign from the middle, put it in the parentheses, square it. Plus z squared, these cancel, and I get 9. So this is going to go on your answer sheet. It will literally say, show the work for the complete the square and the standard form of the equation on the answer sheet. And then on Canvas, you're going to put the answer for the radius, which would be, sorry, not the radius, the center, which would be 2, 3, 0. And then the radius, which would be the square root of 9, or 3. Questions on that one? It has 3 petals, and it's symmetric to the pi over 2 line.
Now that we're just investing in roses, we're 100% gonna get a line of sun. 100%.
I hope that's wrong. I don't remember. I really don't. And then the length, how come this is so slow? Sorry. The length of each petal is 6. Pause. Okay, so 3 petals, pi over 2 axis symmetry means it would have to be folded along the pi over 2. That means 1 loop at the top, 2 on the bottom, or 2 at the top, 1 on the bottom. Those are your only options there. So I'm going to figure out where that 1 happens, where the length is 6. 6 equals 6 sine 3 theta. Divide both sides by 6. 1 equals sine 3 theta. Where is sine 1? It's at pi over 2. So pi over 2 equals 3 theta. Divide by 3. Multiply by a third. Pi over 6 is where one of my petals is. So now I'm going to bring in that graph. I know I have 6 pi over 6 as a coordinate point. So pi over 6, 6 is here. That means I have a loop here. This would be symmetric to the pi over 2 line, which means the other has to happen here. And 3 petals tells me happening down here. How can I check those? By plugging in 5 pi over 6 and 3 pi over 2. So let's just do 3 pi over 2, 3 pi over 2, 6 sine 9 pi over 2. Not on my unit circle. 4 and 1/2 pi would go all the way around my circle twice and end up at the top. Sine there is 1. And 6, we plugged in 3 pi over 2. Confirms that point. I kept thinking we're done at 10. We're done at 10:10. I can just do the limit. I can do the limit escape.
So that one